Let's take a second to talk about bounds. We're going to be considering the accuracy of measurements taken using devices such as rulers, scales, clocks. Since all measuring devices have a limited level of precision, any reading that we take using such a device will have a true value that lies in an interval of real numbers called a bound. What does this mean? Let's say that you are going to get on a scale. The scale that you're using is going to round to the nearest whole number. So when you get on this scale, it says that you weigh 125 pounds. But let's say that instead your neighbor has another scale and their scale actually goes to 1 decimal place. Well, it just so happens that maybe your weight is 124.6 on their scale. Or perhaps your weight is 125.3 on their scale. So the chances that you weigh exactly 125.0 is possible, but the first scale was only rounded to the nearest whole number. And then we can continue this process with another scale that might give you 2 decimal places. So it might tell you that you actually weigh 124.58. Do you see how this goes? So depending on the instrument that you're using, then that's basically the level of precision that you're going to get. So how do you find a bound in one of these problems? Let's work with the example that I gave you about weighing 125 pounds and the scale giving you the level of precision to 1 pound. If you weigh 125 pounds to a level of precision of 1 pound, because remember the scale is going to be rounding our weight to the nearest whole number, then our job is to figure out the bound. What are the possibilities for the weight, for my weight, let's say. So what we're going to do is follow the following steps. Step 1, we're going to take the level of precision and we're going to divide it by 2. Step 2, we're going to subtract from and add to the given value. So in this problem, the level of precision is 1 pound. I will take 1 divided by 2, which gives me 1/2, 0.5. I'm going to subtract 125 minus 0.5, and that's going to give me 124.5. Then I will take 125 and I'm going to add 0.5, and that will give me 125.5. So basically I am subtracting from and adding to whatever amount they gave me. Last but not least, I'm going to rewrite this as an inequality. 124.5 is less than or equal to, I'm going to say W for weight, but I could have used X or whatever the variable they want us to use, which is less than 125.5. And notice the first inequality is less than or equal to, the second inequality is less than, because we're basically going up to any number that's as close as possible to 125.5, but not equal to 125.5. Because if the number is equal to 125.5, then it would round up to 126, okay? So the first inequality is less than or equal to, the second inequality is just less than. So this is what my final answer would be. Let's say that the problem says to find the bound for the following measurements given the following level of precision. Let's say we have a mass of 23.4 with a precision of 0.1. You are going to take the level of precision, in this case 0.1, you are going to divide it by 2, which is 0.05. Then you're going to take the value that we're talking about, which in this case is 23.4 kilograms, and we are going to subtract from, so we'll take the 0.05 and subtract it from 23.4, and we're going to add 2. We're going to add the 0.05 to 23.4. So that's going to give me 23.35 and 23.45. So then the bound is going to be 23.35 is less than or equal to, we can use m for mass, which is less than 23.45, and there I have created my bound for this problem. So no matter what they're asking you to do, the steps are always the same. You take the level of precision, you divide it by 2, you subtract it from the value they give you, and you add it to the value they give you, creating this inequality where the first inequality symbol is less than or equal to, and the second one is less than. I hope you found this video helpful. Remember to subscribe to my channel for more help with math so that you can say, yes, I can do math with confidence. Until next time, thanks for watching.